Welcome to another episode from the Veterinary Research Channel. Today, we delve into a fascinating study published in the Journal of Veterinary Internal Medicine in 2024, which investigated a potential biomarker for a challenging neurological disease in horses known as neuroaxonal degeneration or degenerative myeloencephalopathy. This condition has become increasingly recognized as a significant cause of neurological issues in these majestic animals. Currently, diagnosing neuroaxonal degeneration and degenerative myeloencephalopathy relies on a combination of clinical observations and ruling out other possible neurological diseases. While preliminary diagnoses can be made based on typical characteristics, clinical signs, and certain diagnostic test results like normal cerebrospinal fluid cytology, negative infectious disease tests, and unremarkable imaging, a definitive diagnosis can only be achieved through a post-mortem examination of the horse's brain and spinal cord. Beyond just diagnosing the disease, understanding its underlying causes and how it develops presents considerable challenges due to its complex nature, involving both genetic predispositions and environmental factors. Previous research has indicated that abnormalities in vitamin E metabolism, or a deficiency in this crucial nutrient, alongside a genetic susceptibility, likely contribute to this neurodegenerative condition. Vitamin E is a vital antioxidant for the central nervous system, and insufficient levels due to either dietary lack or impaired metabolism are expected to increase damage from oxidation within the central nervous system. In some instances, horses might consume adequate amounts of vitamin E and have normal metabolic processes, yet still experience heightened oxidative stress because of environmental influences, such as exposure to insecticides, wood preservatives, and contaminated environments. Given that evidence of oxidative stress has been found during post-mortem examinations of horses diagnosed with neuroaxonal degeneration and degenerative myeloencephalopathy, studies have sought to understand its role in the development and progression of this disease. Markers of oxidative stress, such as biomarkers indicating the breakdown of fats in tissues, have shown elevated levels of certain cholesterols and oxysterols in the spinal cords of affected horses. In human medicine, various biomarkers, including a molecule called 8-hydroxy-2'-deoxyguanosine, have been studied in the context of neurodegenerative diseases and have recently been implicated in similar neurological conditions in horses because of parallels in how these diseases develop. In horses, other markers like F2-isoprostane, 4-hydroxynonenal, and 3-nitrotyrosine have been detected in tissues, suggesting that oxidative damage within the central nervous system is a characteristic of neuroaxonal degeneration and degenerative myeloencephalopathy. However, a reliable assay based on cerebrospinal fluid or serum to detect oxidative damage in living horses has been lacking. 8-hydroxy-2'-deoxyguanosine, often abbreviated as 8-OHdG, is a widely recognized biomarker of oxidative damage. It is an altered form of a DNA building block that arises as a result of DNA damage caused by oxidation. This molecule has been extensively researched in human neurodegenerative diseases like Alzheimer's and Parkinson's to gain better insights into diagnosis, treatment strategies, and how these diseases progress. Considering the similarities observed across species in neurodegenerative diseases, the researchers in this study aim to investigate whether 8-OHdG could serve as a potential diagnostic biomarker that aligns with the post-mortem diagnosis of neuroaxonal degeneration and degenerative myeloencephalopathy in horses. The specific goals of their study were twofold. First, to refine and validate a previously reported method for measuring 8-OHdG in equine serum and cerebrospinal fluid using a competitive enzyme-linked immunosorbent assay, and second, to determine if measurable levels of 8-OHdG in serum and cerebrospinal fluid could be helpful in diagnosing neuroaxonal degeneration and degenerative myeloencephalopathy in living horses. Their primary expectation was that 8-OHdG levels would be elevated in both serum and cerebrospinal fluid of horses with neuroaxonal degeneration and degenerative myeloencephalopathy compared to horses with other neurological diseases, such as cervical vertebrostenotic myelopathy and equine protozoal myeloencephalitis, as well as a control group of neurologically normal horses. They also hypothesized that 8-OHdG levels would be higher in cerebrospinal fluid compared to serum in horses with neuroaxonal degeneration and degenerative myeloencephalopathy. Now let's move on to the findings of this research. After optimizing and validating a commercially available enzyme-linked immunosorbent assay, the researchers were able to detect 8-OHdG in both the cerebrospinal fluid and serum of horses. However, their analysis revealed that this biomarker did not prove to be a reliable tool for diagnosing neuroaxonal degeneration and degenerative myeloencephalopathy in the group of horses they studied. Upon carefully considering various factors that could influence the results, no statistically significant link was established between an increase in this biomarker and the presence of the disease or its ability to predict a post-mortem diagnosis of neuroaxonal degeneration and degenerative myeloencephalopathy. Furthermore, no correlation was found between the concentrations of OHdG detected in the serum and the cerebrospinal fluid of the horses. Specifically, when comparing the median concentrations of OHdG across the different groups, the researchers found the following levels in cerebrospinal fluid. For horses with neuroaxonal degeneration and degenerative myeloencephalopathy, the median was 169.9 picograms per milliliter. For horses with cervical vertebral stenotic myelopathy, it was 157.1 picograms per milliliter. For horses with equine protozoal myeloencephalitis, it was 131.4 picograms per milliliter, and for the control group of neurologically normal horses, it was 149.8 picograms per milliliter. In serum, the median OHdG concentrations were 130 picograms per milliliter for neuroaxonal degeneration and degenerative myeloencephalopathy, 125.8 picograms per milliliter for cervical vertebral stenotic myelopathy, 120.6 picograms per milliliter for equine protozoal myeloencephalitis, and 157.6 picograms per milliliter for the control group. Statistical analysis using tests designed to account for the non-normal distribution of the data and regression analysis to control for potential confounding factors like breed, age, the time elapsed since sample collection, and vitamin E concentrations, did not reveal any significant differences in OHdG levels between the disease groups and the control group. Finally, let's explore the implications of these results as discussed by the researchers. While oxidative stress is thought to play a role in the development of neuroaxonal degeneration and degenerative myeloencephalopathy in horses, the exact cause, timing, and its overall contribution to the disease remain unclear. It has been proposed that cases of this condition may have a genetic basis along with a possible vitamin E deficiency or an imbalance in oxidative processes early in life. Although OHdG is recognized as a marker of oxidative damage, it is not known whether its levels remain elevated in the central nervous system over time, or if it is cleared after an initial damaging event. In contrast, in progressive neurodegenerative diseases in humans, increased concentrations of OHdG are typically observed, suggesting ongoing production of this biomarker. The researchers' initial expectation that OHdG would be higher in horses with neuroaxonal degeneration and degenerative myeloencephalopathy, similar to what is seen in human neurodegenerative diseases, was based on the idea that the disease involves continuous oxidative damage. However, the findings suggest that the underlying mechanisms of neuroaxonal degeneration and degenerative myeloencephalopathy in horses might involve an early triggering event, genetic susceptibility, or a combination of factors, rather than a sustained process of oxidative damage at the time of diagnosis. The potential protective effect of access to green pastures for foals against equine degenerative myeloencephalopathy has been discussed, possibly due to the vitamin E content. Low vitamin E levels and limited access to pasture during the first year of life have been implicated as contributing factors in several studies. Interestingly, when the researchers accounted for vitamin E concentrations in their analysis, no difference in OHdG levels was observed between the groups. This further supports the idea that perhaps ongoing oxidative damage is not a prominent feature in horses with neuroaxonal degeneration and degenerative myeloencephalopathy at the stage when they are typically diagnosed. When comparing neuroaxonal degeneration and degenerative myeloencephalopathy with other neurological conditions like cervical vertebral stenotic myelopathy, it is possible that the ongoing damage within the central nervous system in conditions like the latter could explain similar concentrations of OHdG. In cervical vertebral stenotic myelopathy, inflammation within the central nervous system has been suggested as a consequence of chronic or intermittent spinal cord compression and subsequent recurrent trauma. However, information on inflammatory markers was not available for all horses in the study, making it difficult to fully assess the role of systemic inflammation. In cases of equine protozoal myeloencephalitis, systemic inflammatory markers are generally not elevated. Given that the diagnosis of equine protozoal myeloencephalitis might occur after the initial infection, the possibility of early systemic inflammation contributing to increased reactive oxygen species and oxidative damage cannot be entirely ruled out. The researchers also referenced a previous study that measured OHdG in horses with asthma, a condition also thought to involve oxidative damage. That study reported elevated OHdG levels in asthmatic horses using the same commercial enzyme-linked immunosorbent assay. However, The current research team encountered difficulties in replicating those results initially and achieving measurable concentrations of the biomarker, possibly due to variations in methodology. After optimizing and validating the assay, they were able to obtain detectable values. Notably, the control group in this study showed higher concentrations of OHdG than those reported in the asthma study, the reasons for which remain unclear but could involve differences in methodology or systemic inflammation, as comprehensive blood work was not available for all horses in either study. The researchers acknowledged several limitations of their study, including its retrospective case-controlled design and the incomplete clinical history available for some horses. Despite calculating the necessary sample size, not all diagnostic test results were available for every horse, which could have influenced the statistical analysis. The importance of vitamin E concentration on OHdG levels could not be fully evaluated for all disease groups. Additionally, the exact role of OHdG in horses compared to humans is still not fully understood. They suggested that if OHdG is primarily associated with active and ongoing oxidative damage, then other neurological diseases with such processes, like cervical cerebrospinal myelopathy and equine protozoal myeloencephalitis, might indeed show similar or even higher levels than neuroaxonal degeneration and degenerative myeloencephalopathy. The limited number of studies investigating this and similar oxidative damage biomarkers in horses currently restricts its use in routine clinical practice. The researchers proposed that exploring other markers of oxidative damage or different metabolites in equine cerebrospinal fluid might be more fruitful for developing diagnostic tools. They also suggested that before dismissing OHdG entirely, future studies focusing on younger, at-risk horses with inadequate vitamin E status might provide further insights into the early stages of neuroaxonal degeneration and degenerative myeloencephalopathy. Furthermore, employing different methods for measuring OHdG beyond the commercial enzyme-linked immunosorbent assay used in this study could potentially yield different results. Thank you for listening to the Veterinary Research Channel. A link for the reference paper is in the video description. Remember to test your knowledge by answering the questions in the description, and as always, keep those minds inspired, hearts light, and tails wagging.